Okay, so your final exam is Wednesday. Final is December 10th at 7:30 a.m. No, I'm kidding. 12:30 p.m. to 3:15 p.m. right here. It's right here in this building. At 12:50. That yeah. That's what they give you a 15-minute break. So that's our final. Okay. That means we do not have class Monday. There's no class Monday. All right. That's pretty standard. You should not be meeting twice next week for any class. Um, so we'll talk about the final in a second. Let's talk about the exam because we can finally talk about it, except I still have at least one person needs to take it. I posted all the grades. I've graded everything that I have. I want to give everything back. So I'm going to call your name, and then I'll give you a sheet of paper here, and I'll explain what it is after I hand it out. So please come up. Let me pause my video because I don't want to be calling everyone's names on my video. I have to not ever post this video. So here's what I saw, all right? Here's what I saw on the test. There appears to be a basic understanding of what you're supposed to do. I think everybody is comfortable with the idea of, okay, on this problem I need to do this. The problem I saw is that you still are having trouble with derivatives. So like if I give you something like x squared times 7 to the 3x, everything, like it seems like the walls come caving in. Like because it's 7 to the 3x instead of e to the x, it's like it's a completely different problem or something. So what that demonstrates to me is not being comfortable yet with taking derivatives to the point where you can pretty much handle anything. You know, like give me a quotient rule, I'm gonna be able to do it, and that's just because you haven't had enough practice. All right. That was my instinct. That's what I kind of realized. I'd say, well, you know, if they would have got the derivative right up here, then everything else would have been fine, but the derivative wasn't right. Any opinions on your end? I think everyone thought it was a hard test. Let me break the test out real quick. A lot? Mm-hmm. Yeah, there's a lot here. Yeah. There's a lot of material here. Yep, I agree. Man, the one number 8, my goodness. I was shocked at what a difficult time people had with the algebra of this problem, number 8. So I will talk more about this stuff in a second, and we can actually get into specific problems. But let's just go through the grades real quick. I gave you a slip of paper, right? Let me tell you what the paper means. It has your name on it. That's the first thing, and then there should be 4 numbers, right? All right, the first number that appears there is your grade in the class right now. Out of 100, that's your average. All right? The next 3 numbers that appear are what you need on the final to get an A. The next number is what you need to get a B, and the next number is what you need to get a C. So, for example, if it says, I don't want to use that one. I'm just making this up. Let's say it says 82, and then you need for a B a 77, for an A maybe it says 101, and then for a C maybe it says like 47. I'm making these up. These are all. Well, that's yeah. Everyone's got their own numbers, right? So if your number for A is over 100, that means you're going to need a lot of bonus, which is probably not going to happen. So that's just telling you that A is probably not possible. All right. And if B says 77, that means you need to get a 77 on the final to keep a B in the class, and then you need a 47 to pass. How many what? Points? It's going to be out of 100, like 100 points, 100%. Or you're saying, am I going to like build in bonus to it, or? Okay, so the way I graded this, I don't remember actually. I did it one of two ways. I either counted each problem worth 10 points or each problem worth 20 points. It was either 10 or 20. And so, like, if it was out of 10, if it was 10 points each, then you could have 130 possible points. You divide that by 130, you know, like, let's say you missed 30, you would have 100 points out of 130. So I just set up a ratio and get a decimal. Yes. If you got a 76, if this was you and you got a 76, you would have a C in the class. That's right. You must get 77 or higher in order to get the B. You're right, and I round up. I'm not gonna make an 89.4, but you know, make you miss your A, let's say. But at the same time, I'm not gonna. Yeah, if you have an 86, if you have an 86, it's gonna be a C. And that's just because you're a Lakers fan. Okay, so look, the hardest thing for me at the end of the semester is when a student comes in and they've got a 67 in the class. And they email me, you know, what can I do? I'm 3 points away. And I mean, I cannot adjust everyone's scores. I can't offer you anything else. That's where the numbers fall. That's where they fall. Now, if you're within a few decimal points of passing, we're good. If you're a point or two away, I've offered bonuses this semester. You know, there's only been a few of you who've actually come in and gotten help from me. So you've had an opportunity to improve your grade the entire semester. It's not going to happen after you realize you were that close. It's kind of after the fact. And it's not to be mean, but what happens is if I curve someone 2 or 3 points, the entire class gets curved 2 or 3 points. It's not fair to just do it for one person. So, you know, that's right. But then what happens, let me tell you what happens. I curve everyone, right? And now the person who had the 64 is now just 2 points away. And, you know, and then they're like, I need to. And then next thing you know, everyone's getting curved. And then so it's just the grade you earn is the word I stress, is the grade you earn. All right? There are people in this class that can achieve an A still. And there are people who are going to it's going to be very unlikely for them to pass the class. That's the way it is. Calculus is this way. I've tried. Hopefully, you've met the challenge. You can only be honest with yourself of whether or not you put in the time and effort. You know, I know. I've seen a few students in this class who have come a long way. In fact, I think one of the best grades on the test, this test, came from a student that I know works hard. So, and didn't necessarily start the course that way. So, you know, this is all. We're at the end now. Okay, it's hard to become a super math student now. You know, we all kind of know where we are. What's that? Not really. No. 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 Everything you've turned in is here. Yep. Yep. So if you're concerned about your grade at all, I'd be happy to talk to you. Come to me after class. We can sit down in my office. We can talk about your grade. Yes. I may have. Oh, no, you took yours yesterday. Yeah, I don't have it yet. Okay, now let's talk about the final, right? The final exam, what it's going to cover. Well, it's going to cover more of what you just did on this exam because the class average was, did anyone happen to look at it? 50 something on this test? Seems about right. It was pretty low. So that means there's a lot of material here that still needs to be understood. And let's see my Cal 2 people. Okay. Right. Do what? Is it closed? Uh, so what are the things that we should talk about? Off the first exam, continuity, calculating limits. Yes. Yeah. What I will do, okay, what I will do is when I get back to my office, I'm going to do this for my other classes too. I'm going to post all the exams that I've given you this semester with all the keys. All right, so you have something to go back and refer to. All right. My recommendation for reviewing for the final is to go through each exam and work through the problems. All right. Now, I will help you by highlighting the types of problems that I think I would ask. So that's what I'm going to do now. I'm going to go through each exam. I'm going to look at the problems that I like. These are the types of problems I would like to put on a test. And then what I'll probably do is do one maybe like it, all right, similar to it. That sound like a plan? All right. So let me bring up exam 1. I don't know. I mean, yeah. I can't imagine more than 20 problems, but remember you're given almost 3 hours. So you want to come in fed and rested right after your engineering final, yeah. Okay, a farmer wishes to build a pen. That won't be on this problem won't be on there because this, do you remember this? This was what kind of blew me away, this test. This was number 10 on this test, right? Pretty much. Except we were going to do the calculus on it. It was the first problem on the first test I ever gave you. Just setting up the equation properly is what we did back then. And that's still what people had trouble with, just setting up the actual function. So I won't ask you this in this form. It'll be later on, you know, like the one on test 3. So it won't be like that. Let me see. The next one. Oh, limit. Y'all like these? I don't really care for those. Nor do I care for that. Now we're talking. Okay, so these are some limits, right? You'll have some limits like this. But see, now you're equipped with L'Hopital's rule. These limits are trivial now. Like if I asked you to do these now, this would be very easy. Because this, well, what would this go to? 0 on top. I don't think the bottom is 0 there. The bottom's not 0, so that's just, you just plug in and that's it. But this one would be 0 over 0. So what would you do? L'Hopital, right? Derivative top and bottom, which would give you 2x over 2x, which is just 1. Minus 2. And then you go one more time. So, yes? I mean, that sort of thing. So I will highlight this. I do think you would have something like this. Yes, something like that. This was the one where you had limit x goes to 3. On the top, we're going to 6. The bottom's going to what? 0. So you have fixed over something that's becoming small. What's going to happen? Fixed over 0, infinity, or negative infinity, or does not exist. Okay? So that's something you'll see. Oh, these sucked. Do you remember this? You would like peel the sign apart and then rewrite them and try and figure out what's happening, and you would like introduce this thing on top and bottom. Do you remember that? A long time ago. But with L'Hopital's rule, it's nothing now. Again. Let me see. Oh, no, on my key it won't show that because we didn't have L'Hopital's rule when I did this problem. But you'll be able to check the answer. Yeah, I think that's, all these limits are important because limits never seem to go away in calculus, all right? What happens as x goes to infinity here? Well, you get infinity over infinity. So you could use L'Hopital, but it gets uglier if you use L'Hopital. So this is the one where we came in with something on the top and bottom here and multiplied it through, 1 over x squared. Maybe I should bring the key up instead of, let me see. I don't know if I have the key here. Oh, there we go. Now let me bring the key up instead. Might be more valuable for us to look at it this way. Yeah, x goes to infinity, right? So what did we do? We introduced 1 over x squared top and bottom, multiplied it through, and then came out to be 0. This one, x goes to 4, we get 0 over 0. We could use L'Hopital's rule here, but you could also multiply by the conjugate. I'm not highlighting these. These look familiar? Okay. So all that's good. Okay, what else? Oh, killing me. You're killing me. Exam 3, infinity minus infinity. What do? We try and factor, right? Everyone struggled with the factoring one I gave you there. So I'll do that one today, later when we get to the test. The natural log x one? Yeah, okay. So look, how about this one? X goes to infinity, cosine squared x over x cubed plus x, bounded over infinity, goes to 0. These are things you've got to, you're gonna need later again in Cal 2. You're gonna need to remember these things, so you got to know how to do that. This one, infinity minus infinity, you factor out x squared, then you get infinity times infinity, and that's something you can't figure out. Does not exist, sine x, it's oscillating. Nope. That was it? That was the first test? Wow. Okay. So limits. You need to know limits. I'm not going to ask you to draw graphs. I'm not going to ask you to look at a graph and find limits. It's just purely algebraically what are limits, right? What limits turn out to be. Exam 2. I may not have the key here. Use the limit definition to find the derivative. Nah. You want this one? That's the one where you have to do like limit h goes to 0 of f of a plus h minus f of a over, no? Okay. Yeah, I won't have anything like that. I wouldn't ask you to find this derivative. Well, maybe, after what I saw in the last test, maybe. Yeah, let's say that's fair. Yes. That's right. That's right. Because in Cal 2, it's not going to be like, hey, take the derivative, but you're not allowed to use it, you know? So how would you do this? How would you do this? Break it apart into 1, 2, 3, 4 different terms, each of them over t squared. Then do a power rule on each one, right? Now, what would be the other way that you could do, but would quotient rule? But that's more like, all that would show me is that you see a quotient and you automatically turn on the quotient rule. You know, like you're not thinking about what you can do to it algebraically first. If y is this, find where the tangent line is horizontal. We'll get to that. Find where the tangent line is horizontal. That just means you do what? Take derivative, set it to 0, right? Take derivative of that, it's quadratic. It's not really interesting. I like that one. Position of particle is given. When is the velocity of the particle 0? What is the acceleration of the particle after 3 hours? So second derivative gives you the acceleration function, and then you just evaluate it at 3, right? Again, plug 3 into the derivative, second derivative. Yes? Yes. Or did you say log differentiation? Did you say logarithmic? You could do that, yes. My only concern would be, this would be your u, right? This whole thing? Mm-hmm. Okay, let's address this. This is a good question. Let's say that I'm going to call, instead of f of t, I'm going to call it y. You're saying break it up into separate terms, yes? Everyone agree I can do that? Okay, what now? I'm listening. So do the logarithmic differentiation now. Okay, that's why I say I think this is a good question. Can you? That means you have to take log on both sides of the equation. So if I take the natural log of y on the left, that's fine. But if I take natural log of y on the right, I have to take natural log of the entire thing, don't I? And the natural log of a bunch of stuff added together is not the same as the natural log of each one. What I'm trying to get at is, like, let's say I had in here log of a plus b plus c plus d. That does not equal natural log of a plus natural log of b plus natural log of c plus natural log of d. So when you apply log on both sides of this equation, right here, right, you do log y here, but on this side you do not do log of each one, because that you're not allowed to. You can do log of the entire side, but then you're going to be really in trouble, because now you try and take a derivative. You have to take the derivative of the log of all of this stuff. It's going to be a mess. So the cleanest way is just to take it to here and use properties of exponents. No logs at all. Does that address your question? All right, let's get back to where I was. Position, particle thing. I definitely think y'all need more practice with derivatives. So I'm going to highlight this. You need to practice chain rule, quotient rule, product rule, all of that. You need more practice. And it's really because of the last test. The last test indicated you know what you're supposed to do, but if you can't do the derivative, then you're stuck, right? I'm supposed to run the race. I know the route. I don't have shoes. What's that? You don't need shoes? All right. Okay, so this is what? Some quotient, right? Quotient rule. This one right here. Chain, right? Chain with some product. This one, product with some chain. Chain. That was a trick question on the test. I remember that one. Implicit differentiation. What do y'all think? I'll give you something nice, but I'll keep it kind of on the lower end of things. I won't make it real complicated. I don't think so. Y double prime. Here we go. Sphere is growing at a rate. So you will have a related rate problem on the test, but it will be much like this one would be. You know, a sphere, radius type thing. A pretty simple geometric shape. I'll talk about these. I'll go through some of these in a minute. I just want to go through all the tests first and look at what we're gonna focus on. That's it. That's the end of it. Pardon me? I highlighted. No, I did not. And that brings us to the last test. There's different versions of the test, yes. But I think, in fairness, Tamikis, you need to leave the room. Just to be fair to everyone else in the class, I don't think you should see any version of what they saw, right? Just to be fair? Yes? We'll call you back in just a minute. Yeah, he's recording. I'm recording shit. He's taking tests right after this class, so I just want to make sure. Okay. Yes. So should we go through this? All right. What do we have here? Some chain rule, right? Some inverse trig stuff. A lot of you got the derivative of the inverse trig, but didn't get the other parts of the chain rule. All right, so let's try this. Y prime is, so what is the outer function here? What's the outer function? What's the last thing happening? The inverse tangent. So what is the derivative of inverse tangent? So go into your formula sheet. The derivative of inverse tangent is 1 over 1 plus that whatever it is squared. So it's 1 over 1 plus that something, but then squared. Okay, so at that point you have taken the derivative of the arctangent part of the problem, right? Now you move to the next function inside, which is square root of something. This is the part that a lot of people miss. What's the derivative of the square root of something? 1 over 2 square roots of that something. And then there were a lot of people that did get this, but then forgot, now take the derivative of what's inside the square root times 2x. Right? And I probably would have given you full credit if you just got that. But these twos cancel. And then notice here, if you square the square root, it goes away, right? And so you just get 1 plus x squared minus 1, which is just what? 1 over x squared. But then I have that x that was over there over the square root of x squared minus 1. So my x up here, I just pulled it up here, and then this, everyone okay with this becoming 1 over x squared? And then now this, one more x can cancel. So I get 1 over x root x squared minus 1. That would have been it right there. Okay? Next one. Oh man, there was a lot of issues here too. product rule, right? You have product rule here. And I'm not quite sure, what is it? I mean, you tell me, what is it? You see that, and do you start to panic? I mean, do you see the test and start to panic? I mean, what's the, you just blanked out? Okay. You what? It just looked wrong? Yeah. Okay, so the product rule, it was that spice cake. We were all feeling kind of loopy, weren't we? You sabotaged us. Elizabeth, you sabotaged the class? Good job. You were hoping there would be a big curve because you made everyone all messed up? Right. So, product rule, right? Okay, so product rule, take derivative of the first one, which is just 2x. And then you just write down the other one. And then this is where the wheels came off for most people. The derivative of 7 to the 3x. Well, we have to remember the difference, right? There's a difference between two rules we have. Derivative of a to the x versus derivative of x to the n. You'll have to keep in mind, I let you have these formulas. There's some instructors don't even let you have these formulas on the test. You should know the difference between these two. And not only that, you should know how to apply them. Derivative of a to the x is itself natural log a. Almost everybody forgot the natural log a. So what is derivative of 7 to the 3x? Well, derivative of a, which is 7 to the something, would be 7 to the 3x itself times the ln of 7. Now finish up the chain rule. You have to consider what was up here. The derivative of what's up here. 3 times 3. Then finish off the product rule. X squared. I know it all looks simple afterward, you know, and you're just, oh, yeah, okay. But that's the whole idea, is that you have to, you know, you got to come up with it. Now, you could clean this up. You could probably factor some stuff out. You could do, let's see, you could pull an x out. You could actually pull a 7 to the 3x out and be left with something. I would have taken full credit if you would have just got that line for me. I would have been happy. But this right here, let me see, I pulled an x and a 7 to the 3x out of here, so I'm left with a 2. And then over here, what am I left with? ln 7, I'm also left with the 3. I'm also left with an x. So I could put 3x ln 7, or I could put, you know, 3 ln 7 times x, however. Or you just leave it as the line above. Yeah, you probably could have done the natural log on both sides. It worked out? Okay. Do y'all want to see it done logarithmic-wise, or yes? Now, the thing about doing the logarithmic differentiation here, and my view of it, is that my fear would be that if you're doing logarithmic differentiation here, it's because somehow you look at that as being a product rule that maybe you're not comfortable with or something. I don't know. Maybe that's what it is. But I think logarithmic differentiation is something you fall back on when it's a derivative you know is going to be a disaster to try and do just traditionally. This one isn't much of a disaster. That's just my view of it. So, but I'm going to do the natural log on both sides. Natural log of the entire right-hand side. Right? Now, this one, I can do this one this way because it's a product. And because natural log of u times v can split into two natural logs. You see that, Lily? Okay. So that's why my next line will be natural log y equals natural log x squared plus natural log 7 to the 3x. I'll just put 7 to the 3x like that. And now you can use the rule of the property of logs that exponents can be dropped in front, right, like this, which which gives you natural log y equals 2 ln x plus 3x ln 7. Yes? Now what? Well, let's get to that in a second. I need to take derivative right now, don't I? So take derivative on the left side, and I get what? 1 over y prime. And on the right side, 2 is a constant. So 2 times a function of x. So what's derivative of natural log x? 1 over x, so that's 2 over x. Plus, now you're saying product, but look, 3 is a constant, right? Natural log of 7 is a constant, isn't it? So this may as well be, all that I circled there, that may as well say 10x, right? Like all this is just a number. What's the derivative of 10x? Just 10, right? So what's derivative of 3 natural log of 7 times x? 3 natural log of 7. Just 3 natural log 7. Does that make sense? No more x there. And you don't need the product rule. You could do it, but that would become, again, and then multiply both sides by what? By y. So if I come in here and I say y prime is equal to 2 over x plus 3 natural log 7 times y on both sides. Y in this problem was x squared 7 to the 3x, right? And if you distribute, this looks very much like what we just had. If you distribute 1x back through here, you get exactly what we just had in the previous problem, like when we did it the other way. It is not. It is not, because 3 times, natural log of 7 is a number. Natural log of 7. Natural log of x is a function. Natural log of 7 is a number. That number times 3 is a number. And so you have a number next to x. So that's what I'm saying. It may as well have been 10x or pi x or 2x or negative 7x. The derivative of a constant times x is just the constant. All right, what's next? What happened here? Is Tamika still out there? I didn't mean to kick him out, but I think it's only fair. Oh, now this one is logarithmic differentiation, for sure. Because this, if you try, and some people did, try to do this with quotient rule. And it's just like, whoa, I mean, yeah, I mean, even if you do get the quotient rule correct, like you could never simplify that. I mean, it's just a disaster. So this will be something that you're going to have to make sure you know how to do. You're gluttonous for punishment, right? You like self-mutilation there. Do you want me to do that? What do you have? X. Wait. Start over. Y is what? Two x plus 1 to the what? All over plus 1? Okay, so those were the two versions of the problems I gave on the two different versions of the test. So I'm being asked to do this one. So what I would do is I would take natural log on both sides of this equation. Is Tamika's out there? You see him out there? Is he okay? He's out there with his cup on the wall. So again, just taking the natural log on both sides. so that I can begin to prepare it to be split apart. I have division, right? So if you have division inside of a log, you can split it up into two logs with subtraction. So I'm going to start there. That means I'm going to rewrite the entire numerator inside of a log minus the entire denominator inside of a log. Like that. And then this first log still has multiplication in it, right? You cannot start pulling 3s and 1/4 out right now. You can't do it. You have to split this one up into 2. So this is going to become natural log x cubed. Now, multiplication is plus, so plus natural log 2x plus 1. And then I still have this other piece over here, but I'm going to rewrite this as natural log 5x plus 1 to what power? 1/2. And this is all equal to natural log y. Which 1/4? That one. Now, I still haven't taken derivative. This is all just algebra, right? Just manipulating things. And then I'm going to take the 3, drop it, 1/4, drop it, 1/2, drop it. Then I'll have a nice clean thing to take a derivative of. So 3 natural log x plus 1/4 natural log 2x plus 1 minus 1/2 natural log 5x plus 1. I will also point out that the 3, the 1/4, the 1/2, or negative 1/2, all of these are just constants sitting in front of functions, right? So if you're going to take a derivative right now, you're just going to ignore those, kind of bring those with you. You just need to know what the derivative of natural logs are. Derivative of natural log of something is always 1 over that something, right? And then you have to go inside and take derivative of what's in there. So what's the derivative over on the left side? 1 over y prime, that's always going to be the same. And then here, derivative of natural log of x, it's going to be 1 over x, but then times 3, so 3 over x. This one, I'll do a little slower. This is 1/4. Now, derivative of natural log of 1 over of 2x plus 1 is 1 over 2x plus 1, but then times the derivative of what's in here, that's chain rule, it's 2. And then we have the minus 1/2 for the next one. And then derivative of natural log of 5x plus 1 is 1 over 5x plus 1 times 5. And things can be cleaned up. Questions? Yes. No. Look, I think this is getting lost. Gets lost. It's pretty common to get lost, okay, with this idea. Look, when we first started, we said the derivative of a constant was 0. We said the derivative of a constant times a function was the constant times the derivative of the function. That means if you have a function attached to a constant, right, with multiplication, so a constant times a function, you want the derivative, you keep the constant there and you take the derivative of the function of x. That is not the same as this, which is f prime g plus g prime f, right? That's our product rule. Now, could you actually treat this like a product rule? Could you take c times f and make it c prime f plus f prime c? Yes, but what's the derivative of c? 0. The derivative of a constant is 0. So what are you going to get? The same thing. So what it shows someone, when someone takes something like 3x cubed, let's say, and someone tells them take the derivative, and they go, okay, here's a product rule. Immediately, anyone who sees someone do that understands that that person does not understand the product rule and how constants are attached because you're not there yet. I'm not saying that's you. I'm just saying that that is one of those things you have to get cleared up, or else you're always going to be wanting to take product rules every time you see products. And that's not it. It's when the constant's there, you just ignore it, as long as the constant's attached to something that has x in it. So that's why in that problem, God, how long was this damn test? There we go. All right, so constant times a function. Constant comes down, derivative of the function, derivative of natural log x is 1 over x. Make sense? Okay. Can I stop here? Yes? Okay. Next one. Same thing, right? Logarithmic differentiation. Anyone want to see that one? Yes? Natural log y on both sides. Why am I doing it with natural log y on both sides? That's right. The variable x is appearing both in the base and in the exponent. Both, right? Anytime you have that, you want to come in with the logarithmic differentiation. I pull that x squared out front. Right? And now at this point, I take my derivative. So here comes the derivative. What do I have going on over here? Product, right? The product is between the x squared and the natural log, right? That's where the product is. So I have to take derivative of the first one, which is 2x, then times the natural log cosine x. Then I say plus. Now the derivative of natural log of something, 1 over it, times negative sine x, that's a derivative of cosine, and then finishing off product rule, x squared. By the way, what is negative sine x over cosine x? Negative tangent x. So you could have put 1 over y prime equals 2x natural log cosine x minus x squared tangent x. That wouldn't be wrong to do it that way, right? And then you have to multiply both sides by y, and that's good enough. So y over here, y's gone over there. And of course, you have to write what y is, right? You need to put y is cosine x to the x squared. That resolve that? Good. Find the absolute max and min of this function. I think there are a lot of people did do okay on this one. When you find absolute max and min, right, on a closed interval, you just need to find the critical numbers. Take it easy. So what is the derivative of 1 over x? Derivative of that is close. Negative 1 over x squared. How is that? Because that's x to the negative 1. Right? That's what this means. 1 over x is x to the negative 1. So if I take derivative, I get negative 1 x to negative 2. So 1 over x squared. And then what's derivative of natural log x? 1 over x. And now I need to know when that's 0, right? And I need to know when it's undefined. So where's this 0? And this is where, again, this is just like, it's like some of you were just like on a different planet as far as the algebra that you wanted to do. You were making it so much more difficult than it had to be. It's like as soon as the fractions were there, it's like, oh my God, what do I do? So how do you figure out when something's equal to 0? What have I always tried to show you to do on the left-hand side? Try to get it all together, right? Like combine these two terms together. Get a common denominator. So what would I have to do? Just do an x on top and bottom on this one so I get an x squared, right? Yes? Okay, so what would I have here? I'd have negative 1 over x squared plus x over x squared equals 0. Now put them together. Negative 1 plus x over x squared equals 0. The only time that a fraction can be 0 is if the top is 0. Which means x must be 1. Is x inside your interval? Yes. Okay. Next thing I have to do is take into account if the derivative is ever undefined or not exist. At 0, right? But 0 is not in the interval. Now, right, the derivative is right here. If I try and plug 0 in, I get division by 0, so I can't do that. So I say 0, but then I say, wait a minute, I'm only looking between 1/2 and 4, so I throw it, chunk it. I don't need it. So once you find the critical numbers, which is only 1, all you have to do is plug that into the function, the original function, plug in the endpoints into the original function, compare, and you're done. So I wanted you to look at what's f of 1/2. That's what the endpoint. The other endpoint is 4. Then the critical number we just got is 1. You plug those in. I don't remember which one's the biggest, but 4 is the max, and then 1's the min. Okay. I just want to tell Tamika we're going through this. Are you cool being out here? Because they are asking all sorts of questions. Okay. All right. All right. Let's keep moving on. What about this one? Oh my gosh. The e to the negative x, man. That just, again, see, this is what I was trying to get at when I was talking about this in the beginning. It's like, if I tweak a problem a little bit, like if I change it, it's just like all of a sudden things get like, go crazy or something in the head. Look, so you're looking at that. A lot of you just left it as that and said, hey, product rule, right? That's fine. But I'm just going to show you, well, you tell me, you want product rule, or do you want me to rewrite it like this and do quotient rule? You want to do product? Okay, I'll do product. All right. But you do realize you could do it the quotient rule also, right? Just drop that e to the negative x down. All right. So product rule would be derivative of the first one, which is 1, times e to the negative x, plus derivative of e to the negative x is itself times the derivative of what's up there, negative 1, times x. So you get e to the negative x minus x e to the negative x. There's your derivative, folks. Now what do I need to do with it? Set it equal to 0, right? And figure out where it's undefined, if it is ever undefined. The derivative being 0 means you need to set e to the negative x minus x e to the negative x equal to 0. And this is where people start, I think, getting confused as to what to do. You pull out an e to the negative x because they both have an e to the negative x. Everyone agree that that's a legitimate legal algebraic move there, right? Pull out an e to the negative x. That's fine with me because that's now I have two factors. I can set each one equal to 0. So when is e to the negative x equal to 0 is one thing I'm going to ask. The other thing I'm going to ask is when 1 minus x equals 0. So when is e to the negative x equal to 0? Never. Now, how could you convince me of that? Well, you could do this. You could go back to what I suggested earlier, and you could look at it as a fraction, like this. And a fraction can only be 0 when? When the top is 0, right? This can't ever be 0 then, because the only way to make that fraction 0 is if 1 is 0 and 1 can't be 0. So impossible for that to happen. What else? Over here on this other one, x is 1. And it just turns out the way the problem worked that x equals 1 is a critical number, but it also happens to be one of the endpoints. So it really turned out all you needed to do was check the endpoints. But I still wanted to see the algebra of you figuring out what the... So f of negative 1 and f of 1, figure out what those are. Which one was the min? Negative 1? Is x equal what? 1 right here? Is add x to both sides. Oh, yeah, no, the endpoints. I'm plugging the endpoints in. And it turns out that one of the endpoints is my critical number. So I only need to check the two endpoints. But I wouldn't have known that unless I had done the work here. So we get a min here, right? Yeah, if you plug them in, you'll get negative 1 e to the negative 1. Right? That's what happens if I plug negative 1 in to the original function. I get negative 1 e to the negative 1. So that's just going to be negative e to the positive 1. So just negative e. And if I plug in 1, I get 1 e to the minus 1, which is 1 over e. This will be my max. This will be my min. Because your max is a positive number and your minimum is a negative number. Positive number, negative. Mm-hmm. Yes? No, the answer doesn't have to be in the interval. This answer doesn't have to be in the interval. The point you're plugging in has to be in the interval. Yeah. Because all the answer is how high it is. Which after your cookies, we were... No, you understand? You have a graph, right? You have a graph. You're looking at the endpoints. The function's value there is the function's height at those points. Okay. Did you throw out one of the answers because of that? Yeah. Really? I'll look at it. Really? I'll take a look at it. I'm always open to reviewing a problem if you feel like I took off a lot. But I also have to look to see if it was out of 20 points or not, you know? If it was out of 20 points, but I'll look at it if you want. What about this one? I probably won't ask you this, okay? So we can move on. You can what? Oh, yeah. Yeah, that's yours now. I don't need it. No mean value theorem. So I gave this problem on both tests, but I gave them in different versions to see if they would be done the same way or not. And by leaving it this way, a lot of people did product rule for the derivative. But on the makeup test, I wrote it like this. X to the 5/3 plus 5x to the 2/3, which is just what you get when you distribute x to the 2/3 through these two. You see the difference? I'm willing to bet it wouldn't have been, because it's still the derivative is the problem. Setting it to 0 is still the problem. It's still the issue. So let's just compare the derivatives, all right? Let's compare them. If I go here, it would be 2/3 x to the negative 1/3 times x plus 5. Plus, what's the derivative of x plus 5? 1, so x to the 2/3, right? That's what you would have there, if you did it that way. Now, the other one, it was 5/3 x to the, what? 2/3 plus 10/3 x to the negative 1/3. So I'm bringing the 5/3 out, x to the 2/3. I'm bringing the 2/3 out. That's 10/3 x to the negative 1/3. I know a lot of you raised your hand that you're going to take Cal 2. So this stuff cannot be, this can't be a 10-minute, 5 to 10-minute exercise for you from this line to this line, right? It has to be that you've done so many of these problems, you are now doing this power rule in your head. You are doing 2/3 times 5 and knowing that's 10/3, not needing to write down on the side somewhere what's 5 times 2/3. If you're at that point, so where you're writing everything down, you haven't done enough problems. It means you're still relying too much on scratch work to do this. All right? I'm just telling you, that's the way you want to. Repetition is what creates this thing. You know, you don't just automatically become great with fractions. You have to do so much of it that you have no choice but to get good at it. You know? What now? So like on the left one, what did you do? Anyone mess with this on the left? Because you have to set it to 0 at some point. The x to negative 1/3 down? So you did 2 over 3, and you did cube root? Ooh, I don't know. I would leave it as a rational exponent. What about the x plus 5? You distributed it? Anyone leave it? Okay. Yeah, I don't know. I mean, either way, I'm setting this equal to 0, right? I'm trying, if I were doing this, I would be trying to get a common denominator. So like that's over 1. I have like 2 terms here. So I would multiply this one top and bottom by what? 3x to the 1/3. So what would happen if you take, let me get that out here. If I multiply 3x to the 1/3 here, 3x to the 1/3 there. This is just going to be 3x up here. And you have the same denominator now, so you get 3x to the 1/3, and then the top is the 2, the x plus 5 that you haven't touched, and then plus a 3x. And now you can distribute through, and you get 5x plus 5 on top. On the other one, you would probably maybe have done this. 5x to the 2/3 over 3 plus 10 over 3x to the 1/3. Hold on. What's what? Oh, I said 5. So 5x to 2/3, that's this part, and then over 3, and then this one is 10 over 3x to 1/3. I get the same thing here. I multiply these two by x to the 1/3 on top and bottom, and then I get 5x plus 10, which is the exact same thing as what I get here. So either way, you get the same result. You should get 5x plus 10 over x to the 1/3. Set the top equal to 0. What do you get? -2? -2. What about the bottom? A lot of you left off the bottom. I'm leaving out details here, sorry. The derivative equal to 0 means 5x plus 10 must be 0, right? That means x must be -2. That's the first thing I did. Then, because, look, I'm not given an interval here, right? Increasing, decreasing, local max, local min. I need to also figure out where it's undefined. The derivative does not exist or is undefined at the point x equals 0. Because I get division by 0 here, right? So I have two critical numbers. This is where I draw my number line. I plug in test points. Anyone need me to do this part? No? I think it goes, what? Does it go up, down, up? It should go up, down, up. So you have a local max at -2. You have a local min at 0. Because both -2 and 0 exist in the domain of the function. Most of you got that one. Roughly got it. I mean, gave me enough to feel like I felt like you had a good idea what's going on. And you know why a lot of people did well on that one? Because look at the function. It's a polynomial function. The derivative of that's quadratic. Second derivative of that is linear. And so, you know, if the functions are polynomials, most Cal 1 students are pretty comfortable with taking derivative of polynomial functions. But when they become a little more complicated, like x e to the -x, that's when things start getting a little weird, and you want to try and get to a point where you're comfortable with that, where it doesn't have to be a polynomial. It can be rational. It can have square roots in it. It can have weird exponents, and you're okay. Yes? It depends. I mean, the table, if the table was all correct, but you didn't have a graph. What's that? I'll look at it and I'll tell you. What was the issue with this? Is it just the word problem or what? Okay, depending on how you label things, which I'm assuming that you would have. Is that the way most of you labeled it? Okay, then let's start with something different than what we've done before. What is given to you in the problem? Okay, tell me what's given to you. The amount of area, right? The area. You know that the area must be what? The area must be 800. Okay, what is the area of the total area of your enclosure? Is in terms of these variables, what's the total area? XY, not 4XY, right? It's just this length times this length, X times Y. So you know that X times Y is 800. Okay, that's the first piece of information. You know that must be true. Now, tell me what it is you're trying to find the minimum of. The amount of fence, right? Which is a perimeter. So the perimeter of this would be this x plus this x plus, right? Plus this x plus this x, 4 x's. And then you also have 1 y, don't you? But you don't need any fence along the river. So the perimeter, which is the thing you're trying to find the maximum of, must be the 4 x's plus the y. And now, this is my objective function, this is my constraint. I come in here, I replace my y with this solved for y. So what happens when you solve this for y? You get 800 over x. Take that and plug that in right there. Y, what do you want it to be? Yours is different. Okay. Okay, because, all right, so what, if I give you a rectangle, I tell you this is width and this is length, then what's the area? What's the area of a rectangle? Length times width, right? So if I put another thing in here and I call that width and I call that width and that width, have I changed the area of this thing? It's still this side times this side, right? That's the total area of the whole thing? Did I answer it or yes? Okay. So you just need the dimensions of one side and one side up and you have the total area. And then now at this point, what do? This is your objective function, right? Take a derivative, right? You can take a derivative of this and start going to town with it. And I would probably have rewritten it like this before I take the derivative, and now go take the derivative, right? What is the derivative? The derivative would be 4 minus 800 x to what power? Negative 2. So you get 4 minus 800 over x squared. That's your derivative. And what do I want to do? Set it to 0, right? Okay, so if you set this to 0, you get a common denominator. It becomes 4x squared minus 800 over x squared. Set that to 0. So all I did there, right, was multiply x squared on top and bottom here for that 4. X squared top and bottom, and then put them together. Poor Tamikis is out there. He's on Facebook or something now. I don't know. He's on his phone. I gave you 7 out of 10? I didn't take off 7 out of 10? Give me that. Give me that. No. Well, does this make sense now? What is the critical number? So like it's square root 200, right? Now here's something. If you got root 200 and did not do the rest of the problem, I shouldn't have given you full credit. And that's, you have to show that this is a minimum. It's not enough to just find this critical number. You have to now go to a number line. You have to put root 200 here. You have to pick a test point here and here, and you need to show that your function p goes down and then up. So that's what I'm looking for also on that. So I pick maybe something like 1 and maybe something like 200. Plug those into where? The derivative. And if I plug 1 in, I can plug it in, let's say right there. No, right here. Before I came in with the x squared. What's 800 divided by 1? 800, negative, so it'll be 4 minus 800, it's a negative number. Plug in 200, square 200, figure it out, it's going to be less, it's going to be a positive number, and that means it's going up. Okay? And I should just let Tamikis go study for the test he's about to take. Yeah, we're almost done, but hey, Tamikis, you should have come in, man. You should come in and maybe get your stuff and look over it if you want. Yeah, I mean, we're kind of at the end of the test right now, but we've eaten up all this time. Sorry, I didn't realize it was going to take that much. You can hang out though. You can hang out. Yeah, because I'm just going to do some limits now. Any questions on this one? That was pretty straightforward. Not the one on the makeup though, right? That was a little bit more involved. Yeah. You had to use product rule on the top. Did you use product rule on the top? Okay. I can look at that. I can look at that. What's that? Did you say those are way easier? Okay, so yes, the problem on the makeup test might appear harder, but they are directly out of the book. They're homework problems. So it's hard to argue with that when it's a homework problem. Okay, so look, this one, you want to see that one? Okay. By the way, the reason why I don't write down why I'm taking off is because I'm hoping that you will find why I took off. Like you'll look back through and say, why is he taking points off here? You know, instead of me saying, oh yeah, there it is. Well, that means you need to go. Well, when you did that, you didn't have your notes, you didn't have your book, you didn't have anything else. So now you can go back to your notes in your book and you can try and look through and figure out where the problem is. Yeah. I'm saying just in general, I'm telling you why I don't write down it, because I anticipate students would go back and look through it and try and figure it out. I just rewrote it in terms of sine and cosine. And we know that 1 over 0 is going to give you either negative infinity, positive infinity, or does not exist. And then over here, this is also 1 over 0. And that's not going to exist either. So, but there's something you can do. They already have common denominator. And now you have, if x goes to 0, this is 1 minus 1, 0 over sine of 0, 0. So you have 0 over 0. So you use L'Hopital right now. I know, it works out pretty nice. The derivative of the top, sine x, derivative of the bottom, cosine x. And now plug in x is 0. And you get 0 over 1, which is 0. That's okay. Let me see. I marked through this, which makes me think that I should give you that point back. I don't think that there's any reason I should have taken off a point, other than the fact you didn't put a limit here. But I don't think that's not why I did it, because I marked through this. Maybe I thought you took the limit. You didn't do the limit twice. No. Okay, I'll give that back to you. Yeah, no, it's 1 point. This one? This one? Do y'all want to see this one? So this is the form 0 to the 0. Which is an indeterminate form, right? Why is that an indeterminate form? Why is that something that we can't really figure out? 0 wants to be 0, the base wants to be 0, but anything to the 0 should be 1. All right, so what do? Okay, we're going to take the log, but what we're going to do is first write it down as an equation. And that way we can work with both sides of it. So we take the natural log on the left, we do the natural log on the right, and we can do the natural log past the limit. And now we use the property of logs to drop the x squared in front of the natural log. This is not logarithmic differentiation. We are not taking the derivative on both sides, right? This is a limit problem. There's a difference between logarithmic differentiation and using a log to evaluate a limit, right? Even though it looks the same, we took log on both sides, we still pull the power down. The next step, though, is not to take the derivative on both sides. It's just to figure out what's happening over here. So when we do x goes to 0, what happens? 0 times what's natural log of 0? Thank you, negative infinity. 0 times negative infinity? That's the first time the correct answer has come out. That's the first time. Well, no, maybe I just didn't hear you. Sorry. But no, like earlier this semester, right? Didn't I ask like 5 different times, and every time I was like drawing the picture over there? Okay, so finally I think that's clicked. That's a good thing. And hey, doesn't matter. It matters if you make it to the finish line, right? Negative, right? But this is a form, whether or not it's positive or negative, 0 times infinity, indeterminate, right? So I want to figure out what I can do with that. Well, I said anytime we have that, we can do what? Drop one of them down, right? As 1 over it. So I'm going to just rewrite the problem. Limit x goes to 0. Leave the natural log x up there. 1 over x squared is what it comes down to as in the bottom. It does not come down as an x squared. It comes down as a 1 over x squared. Now you should have x goes to 0. That goes to negative infinity. And then the bottom, 1 over 0 goes to infinity also. So now you have infinity over infinity, which is what we've been trying to force to happen, right? So now you can apply L'Hopital's rule. The derivative of the numerator is what? 1 over x. Now, derivative of the denominator, remember, don't do quotient rule here, right? That's x to the negative 2, isn't it? That's x to the negative 2. And derivative of x to the negative 2 is negative 2, x to the negative 3, isn't it? Which is negative 2 over x cubed. I mean, you can do quotient rule. I mean, you can. I'm just saying, what's that saying? Don't work hard, work smart. You've heard that before? Work smarter, hard. Yeah. And now, I'm not going to plug 0 in. I'm going to algebraically simplify this first. The negative 2 over x cubed can flip up, right? And when you flip that up, doesn't it just become x cubed on top, and on the bottom, negative 2x squared? Something like that. When I flip. Yeah, I don't know where the x squared came from. Sorry. And now you can cancel one of the x's, right? When I cancel one of these x's out, this one becomes a 2. You get x squared over negative 2. And now if you let x go to 0, it's just 0 over negative 2. That's okay. That's just 0. So you get, at the end of it all, the left side of the equation, natural log of y equals 0. We need to get what y is, so you do e on both sides. E, natural log of y, using that property. So y must be 1. And y is what we were trying to find. Questions? No. Or negative infinity, or doesn't exist. If you want to, you could actually look at 1 over x as like a graph, If you were to go look at the graph of 1 over x, it would look like this one. So as you approach 0, it actually becomes infinite, right? Well, yeah, you can't actually plug 0 in, but that's the whole idea, is that we're approaching 0. We're taking a limit. All right, so is there anything else that we need to discuss? I've kind of gone through the 3 exams that we've had. I've pointed out the things that you should review. Out of the third, pretty much everything I talked about. I skipped some stuff. No, I'm saying you should study the whole test, everything I looked at. I mean, there are certain things I don't think you should worry about. I'm probably not going to ask you to sketch a polynomial function. I'm not going to ask you about mean value theorem. It is possible for me to ask you something like that. But I'm not saying it's going to be that. I'm just saying that if I were studying, I mean, that's what I would review. Those problems on those tests. And like I said, I'm going to post the tests. I'll post the keys. I'll post those in the next day. All right? I guess that's it, huh? If you have any questions about your grade, then you can get in touch with me. On the grades? Like a 10-point bonus on the end or something. That I just gave you back? No, like on the final. Oh, you want a bonus question?